double bond between carbon and oxygen atoms. This is a functional group of this organic compound with OH. This part is carboxyl group, and that is the functional group of carboxylic acid. The name of this one is, its common name is formic acid. I already told you about that one. Its IUPAC name is methanoic acid. Methanoic, methane. E of an alkane must be replaced by oic acid to write the IUPAC name for carboxylic acid. Okay, carboxylic acids containing, for example, 2 carbon atoms. This one, we have 2 carbon atoms, okay? So, alkane that contains 2 carbon atoms is simply known as ethane. E of an alkane must be replaced by oic acid to write the IUPAC name for this carboxylic acid. Therefore, it is ethanoic acid. Ethanoic acid is the IUPAC name for this organic acid. Its common name is acetic acid. I told you about that. So it is derived from the Latin word acetum, which means vinegar. So this is present in vinegar, okay? That's why it is named as acetic acid. The common name for this one is propionic acid. It is derived from the Greek word propion, which means milk, okay? Therefore, propionic acid is the common name for this carboxylic acid. Its IUPAC name is propanoic acid. Propane, E of an alkane must be replaced by oic acid to write the IUPAC name for this carboxylic acid. Simplest aromatic carboxylic acid is benzoic acid. Benzoic acid is the common name for this simplest aromatic carboxylic acid. Its IUPAC name is benzene carboxylic acid. So don't be confused here. The IUPAC name of this organic compound is benzene carboxylic acid. If, for example, you have substituent on the 4th position, the IUPAC name for this compound is 4-methyl, for example. If you have methyl group on 4th position, 4-methyl benzene carboxylic acid is the IUPAC name for this compound. The common name for this compound is paramethyl benzoic acid. Okay, benzoic acid is the common name for this simplest aromatic carboxylic acid. Its IUPAC name is benzene carboxylic acid. Di and tricarboxylic acid. Carboxylic acid that contains 2 COH group in their molecule. They can be named as dicarboxylic acid. If you have 3 COH group, 3 carboxyl group in the molecule of say type of organic compounds, therefore that carboxylic acid is simply known as tricarboxylic acid. 2 carboxyl group dicarboxylic acid and 3 carboxyl group tricarboxylic acid. For example, look at this organic compound. We have C double bond OOH, 1 carboxyl group on the left, and C double bond OH, another carboxyl group on the right. Therefore, we have 2 carboxyl group in this molecule. Because of this one, this is classified as dicarboxylic acid. What's the name of this dicarboxylic acid? In naming IUPAC name for such type of organic compounds, all the time you must use dioic acid as a suffix. Okay, 2 carbon atom, ethane, then ethane dioic acid, propane dioic acid, butane dioic acid, pentane dioic acid. It continues just like that. But the common name for this dicarboxylic acid is oxalic acid. Oxalic acid is the common name for this dicarboxylic acid. Its IUPAC name is ethane dioic acid. Okay, another example. Okay, look at this organic compound. You have how many carboxyl groups? 2 carboxyl groups. And the total number of carbon atoms in this molecule is 3. And an alkane that contains 3 carbon atoms is propane. So propane dioic acid is the IUPAC name for this dicarboxylic acid. Okay, another example. You have also 2 carboxyl functional groups in this molecule. And the total number of carbon atoms are 4. Therefore, an alkane that contains 4 carbon atoms is butane. Therefore, as the in, you must add dioic acid as a suffix. Therefore, the IUPAC name for this compound is butane dioic acid. Its common name is succinic acid. The common name of this propane dioic acid is malonic acid. Okay, this one oxalic acid, malonic acid, succinic acid. For example, if you have 5 carbon atoms, glutaric acid. So this is butane dioic acid. This is the IUPAC name for this dicarboxylic acid. Another one, aromatic dicarboxylic acid. For example, you have 2 COH groups. Both of them are directly bonded to the benzene ring. Therefore, the IUPAC name for this one is 1,2 benzene dicarboxylic acid. This is the IUPAC name for this compound. So we have 2 COH functional group. You must indicate by number. These functional groups by number, 1,2 position. So 1,2 benzene dicarboxylic, Why? Because we have two COH functional group. Its common name is phthalic acid. This is a common name of this aromatic dicarboxylic acid. 1,3 position. So it is similar with this one. The only difference between the two is just indicating the position of COH group by numbers. So this is 1,2 position, but in this case it is 1,3 position. Therefore it is 1,3 benzene dicarboxylic acid. Isophthalic acid is the common name for this aromatic dicarboxylic acid. Third one is this one, 1,4 position. It is similar with this one. 1,4 benzene dicarboxylic acid is the IUPAC name for this carboxylic acid, and the terephthalic acid is the common name for this aromatic dicarboxylic acid. So these are aromatic dicarboxylic acids. 3 carboxylic group, it is simply named as tricarboxylic acids. I already told you about this one. The best example for tricarboxylic acid is citric acid. In citric acid, we have 3 COH groups. So this is citric acid. COH, 3 COH group. Therefore, it is classified as tricarboxylic acid. How can we name the common names and IUPAC names for carboxylic acid? I already told you how to name the common names for straight chain, aliphatic, saturated carboxylic acid. So we have only one carbon atom. This is formic acid. It is a chemical difference for anthus. It is derived from the Latin word formica, which means ant. I already told you about this one. So formic acid is the common name for this carboxylic acid. Second example, we have 3 carbon atoms. Okay, therefore the common name for this carboxylic acid is propionic acid. So it is derived from Greek word propion, which means milk. Therefore it is named as propionic acid. Carboxylic acid that contains 2 carbon atoms. Acetic acid, it is derived from the Latin word acetum, which means vinegar. I already told you about that one. So this is propionic acid. Another example, okay, carboxylic acid that contains 5 carbon atoms in its molecule. 1, 2, 3, 4, 5. Its common name is valeric acid. It is found in valerian herbs. That's why it is named as valeric acid. Valeric acid is the common name for this acid, the acid that contains 5 carbon atoms. Okay, its IUPAC name is pentanoic acid. The IUPAC name for this compound is propanoic acid. The IUPAC name for this organic compound that contains 1 carbon atom is methanoic acid. So you can easily name, okay, their IUPAC name as well as their common name. The fourth example is this one. For example, if you have substituents, you must indicate by using Greek letters alpha, beta. Alpha is on the carbon directly bonded to the carboxyl group of that carboxylic acid. So this is alpha position, this one is beta position, then gamma position. It continues just like that. Therefore, the name of the substituent must be indicated by this Greek letter. So we have chloro on alpha position, alpha chloro, and the common name of carboxylic acid that contains 3 carbon atoms is propionic acid. Therefore, alpha chloro propionic acid is the common name for this carboxylic acid, alpha chloropropionic acid. Okay, another example. Look at this organic compound. So we have methyl group on alpha position. Alpha, beta, gamma, delta. This is only for common naming system for carboxylic acid. But in the case of IUPAC naming system, you must indicate the position of the substituents or side chains by using Arabic numerals. So we have methyl group on alpha position and another methyl group on gamma position. Therefore, alpha, gamma, dimethyl. How many carbon atoms? In the longest chain, we have 1, 2, 3, 4, 5. So the common name of carboxylic acid that contains 5 carbon atoms is valeric acid. Therefore, the common name of this organic acid is alpha, gamma, dimethyl valeric acid. Okay, so let us come to the IUPAC names for carboxylic acid. I already told you that if you have only 1 carbon atom, the IUPAC name for that carboxylic acid, methanoic acid. 3 carbon atoms, propanoic acid. 2 carbon atoms, ethanoic acid. 4 carbon atoms, butanoic acid. 5 carbon atoms, pentanoic acid. Hexanoic acid. It continues just like that. So it is dependent on the IUPAC names of alkanes. E of an alkane must be replaced by oic acid, methanoic acid, methane, then E must be replaced by oic acid. Metanoic acid is the IUPAC name for this organic acid. Propanoic acid. This one pentanoic acid. 2 carbon atoms. Ethanoic acid. 4 butanoic acid. If we have substituents, how can we write the IUPAC names for those carboxylic acids? So we have methyl group 1, 2, 3 on third position. The structure for this compound is CH3, then CH. On CH we have CH3, okay, then CH2, then C double bond O, OH. This must be carbon number 1 all the time. Then this is 2, this is 3, and this one is 4. We have methyl group on third position. Therefore, 3-methyl, an alkane that contains 4 carbon atoms is butane. E of an alkane must be replaced by oic acid. So 3-methyl butanoic acid is the IUPAC name for this compound. 3-methyl butanoic acid. Similarly, the IUPAC name for this compound, we have methyl group on second position and the chloro on third position. Chloro must come first. Why? Because of its alphabetical order. Therefore, 1, 2, 3, 3 chloro, 2 methyl, 1, 2, 3, 4, 5. 5, okay, pentanoic acid. Therefore, 3 chloro, 2 methyl, pentanoic acid is the IUPAC name for this compound. 3 chloro, 2 methyl, pentanoic acid. Another one, dicarboxylic acid. We have 2 carboxyl groups in this organic compound. So how can we name the IUPAC name for this compound? 1, 2, 3, 4. For butane, E of an alkane must be replaced by dioic acid. Why? Because of the presence of 2 COH groups in the molecule. Therefore, butane, dioic acid is the IUPAC name of this compound. Succinic acid is the common name for this organic compound. Succinic acid is a common name. Butane dioic acid is the IUPAC name for this compound. Okay, if you have, for example, substituents on the benzene ring on this type of organic compound, IUPAC name must be written as 2-bromo, then benzene carboxylic acid. What is the common name for this carboxylic acid? On ortho position we have bromine. Ortho-bromo benzoic acid is common name for this organic compound. So you can also write the IUPAC names for other carboxylic acid in a similar way. Okay, another one, or the last one, is esters. This is the last oxygen containing organic compounds or oxygen derivatives of hydrocarbons. The general formula for ester is RCO or R prime, RCO2 R prime, or RC double bond O, OR prime. This one is detailed general formula for esters. They can be named as alkyl alkanoids. So they are the most widely occurring compounds in nature, and many of them are pleasant smelling substances, and they are responsible for the flavor and the fragrances of many fruits, oils, fats, waxes of plants or animal origin. All of them are esters. So esters naturally available in fruits and responsible for their pleasant fragrances. Okay, some of them are, for example, isoamyl, isovalerate. This is found in apple. So you are familiar about apple. So this is apple. An ester that is found in an apple is isoamyl, isovalerate. This is the formula for isoamyl, isovalerate. Therefore, this ester is responsible for the good flavorance of this apple. And second one is ethyl butyrate. So the formula for ethyl butyrate is this one. It is found in pineapple. So this is pineapple, and it is responsible for the pleasant fragrance of this pineapple. The third one, isopentyl acetate. This is found in banana. This is a formula for isopentyl acetate. Therefore, this is responsible for the pleasant fragrances of banana. Another one is octyl acetate. This is an ester found in orange, and therefore it is responsible for the pleasant smell of this orange. Another one is an ester that is found in grapes is methyl anthranilate. This is the formula for that ester. And the last one is isopentyl acetate. This one is found in pear. So this is pear. We can also write the common names and IUPAC names of esters based on the common names and IUPAC names for carboxylic acid. So this is derived from an alcohol, and this part is derived from carboxylic acid. All the time, naming of an ester must start from the portion that comes from an alcohol. So this is methyl. This one is, for example, the common name of carboxylic acid that contains 2 carbon atoms is acetic acid. Methyl acetate is the common name for this organic compound. Methyl ethanoate. Methyl ethanoate is the IUPAC name for this compound, and then you can also see the names, common names as well as IUPAC names of these organic compounds. For example, this one is the portion that comes from an alcohol, it is named as ethyl. Then this one contains 2 carbon atoms, and this is derived from carboxylic acid, and the name of the carboxylic acid that contains 2 carbon atoms is acetic acid. The common name for this ester is ethyl acetate. Its IUPAC name is ethyl ethanoate. Ethyl ethanoate is the IUPAC name, ethyl acetate is the common name. So look at the common names as well as IUPAC names for these organic compounds. So some of these questions are from university entrance exam questions. Let us answer together. The first question says the first organic compound was synthesized in the laboratory by what? By Frederick Euler. I already told you about this one. A is the answer for this question. Question number 2. The first organic compound that is artificially synthesized from inorganic starting material is what? Urea. Urea is the first organic compound synthesized in the laboratory by Frederick Euler from inorganic compound. What is that inorganic compound? Ammonium cyanide. The correct answer for this question is C. Urea is the first organic compound synthesized in the laboratory, and this is the structure for urea. Third question. Which of the following hydrocarbons does not belong to the homologous series of alkane? So you can use the general formula for alkane, CnH2n plus 2. All the time, if you remember this one, you can easily answer this question. For example, C3H8. If 3, then 3 times 2 is 6 plus 2, 8. C3H8, this is an alkane. C8H18, 8 times 2, 16 plus 2, 18. So this is also an alkane. C6H10, 6. C6, 2 times 6 is 12 plus 2, 14. It must be 14. But here it is H10. Therefore, this one does not belong to the homologous series of alkane, but the last one, C10. 10 times 2 is 20 plus 2, 22. So C10, H22 is decane. This also belongs to the homologous series of alkane. Fourth one, which of the following alkanes is liquid at room temperature? C1 to C4 are gases, C5 to C17. Okay, 5 to 17. They are liquid, so B is the correct answer. And the fifth question, the general formula that represents olefin, that means alkenes. It is CnH2n. So D is the correct answer. Sixth question, which of the following acid is used as chemical difference for anths? I already told you about this one. Formic acid. What is the molecular formula for formic acid? HCO2H. So HCOH, this is formic acid. B is the correct answer. This one is acetic acid. It is found in vinegar, acetum, but this is alcohol. This is not an acid. This one is also an alcohol. It is not an acid. Therefore, B is the correct answer for this question. Question number 7. Which of the following compound is ether? This one COOR. RCOOR prime. This is an ester. RCOOH. This is carboxylic acid. Because we have carboxylic group. This is a functional group for carboxylic acid. CHO. This is an aldehyde. ROR prime. This is an ether. So D is the correct answer. Question number 8. The compound is methanol, and this one is acetic acid or ethanoic acid. React in the presence of an acid catalyst to form what? When alcohols react with carboxylic acid, all the time ester is formed. And this reaction is known as esterification reaction. So D is the correct answer. Chemically, all fats and oils are, I already told you about this one. So all of them are esters. So C is the correct answer. The correct IUPAC name for the following compound. Okay, so how can we write the IUPAC name for this compound? We have OH group, so this is an alcohol. All the time you must start numbering from this carbon atom. Okay, this is number 1, 2, 3, 4, 5, 6, 7, 8. Why? Because this is the longest continuous chain. For we have substituents on third position. That substituent is methyl, and another methyl on the same carbon atom, methyl. And also another methyl group on 6th position. Therefore, 3, 3, 6 trimethyl. Then 2, 8 carbon atom, This is octanol. Therefore, C is the correct answer. Okay. Other options are not correct. Therefore, the correct answer for question number 10 is C. So, this is all about organic compounds. Thank you for watching and thank you for listening. See you next time. Until then, bye-bye.